Welcome. This is Coach Dorf. We're in section 2.5, and we're going to look at an example of a homework problem. This one says we're going to use the intermediate value theorem to show that this given equation, sine x equals x squared minus x, has a solution in the interval 1, comma 2. That means that there's some x value between x equals 1 and x equals 2, such that sine of that x value equals x squared minus x. All right, so there's a big clue on what I'm going to use to solve this problem, and it says use the intermediate value theorem. So what is the intermediate value theorem? And I'm going to abbreviate that from now on as IVT. All right, well, we're given some things, and then we can conclude something. All right, so we're given that the function f is continuous on some closed interval from a to b, and n is any number, any y value between f of a and f of b. And then given this, my conclusion is that there is some number c where c is between a and b. So c is an x value, and it's between x equals a and x equals b, such that f of c is going to equal that n. So that's the given, and then I get this conclusion here. So in solving this problem, the first thing I need to do is I need to have a function f. And they don't tell you what f is here. So we're going to have to create an f. And what I'm going to do is choose f of x to equal sine x minus x squared plus x. All right, so I took my equation sine x equals x squared minus x, and I brought everything over to the left-hand side. Now what I'm going to do is I'm going to show that there is a solution to this where f equals 0. If I can show that there is some c value so that f of c equals 0, then I get the sine of x minus x squared plus x equals 0. And I can bring the x squared minus plus x to the other side, and I get sine x equals x squared minus x. So that's my goal. So I want to use the intermediate value theorem. So first of all, I have to know or explain why f is continuous, or even indicate it. So is f continuous? And it's going to be continuous in some interval. What interval am I going to take? Well, they give you an interval from 1 to 2, so let's take that interval. All right, but it has to be closed, because that's what the intermediate value theorem says. So is f continuous on the closed interval from 1 to 2? Well, yes. Why is it closed? Why is it continuous? Because sine x is a continuous function. X squared is continuous, x is continuous. If you add or subtract continuous functions together, you get something that's continuous. So this is yes. All right. If n is any number between f and a and f of b, then the intermediate value theorem says I can find some x value c so that f of c equals n. So let's figure out what is f of a and f of b. Well, in this case, my a is like 1. So what is f of 1? That's going to be like my f of a. Well, I put 1 in here into my function, and I get the sine of 1 minus 1 squared plus 1, which is the sine of 1. Now remember, 1 is in radians. It's not in degrees. If it were degrees, we'd know it'd be in the first quadrant. But the sine of 1, where 1 is radian, what quadrant is it in? Well, 1, I can figure out, I know 1 is larger than 0. All right. How does it compare to pi over 2? Well, pi is about 3.1. So pi over 2 is larger than 1. So 1 has to be between 0 and pi over 2. And that is meaning I'm in the first quadrant, because here's pi over 2 and here's 0. So we're somewhere in the first quadrant. And if I'm in the first quadrant, the sign is positive. So sine of 1 is positive. All right, now I need to figure out what is let I can get this right. What is f of 2? Well, I'll plug in 2 in here for x, and I get the sine of 2 minus 2 squared, which is 4, plus 2. So that equals the sine of 2 minus 2. Well, what value is that? Is it positive or negative? I don't know what the sine of 2 is. Again, we're doing radians here, so this is the sine of 2 radians, not sine of 2 degrees. If it was sine of 2 degrees, we would know it's positive. But it doesn't really matter what the sine of 2 is in this one, because I know How large can the sine of 2 be? What's the largest it can be? The largest it could be is a value of 1. That's the largest. So sine of 2 is going to be less than or equal to 1. All right. Why is that? Remember, the sine function looks like this. It's a wave. And what's the highest that wave goes up to? It's 1. And the lowest it goes is -1. So the sine of 2, no matter what it is always going to be between -1 and 1. Well, if the sine of 2 can't be larger than 1, and I'm going to subtract 2 from it, what is the sine of 2 minus 2? Well, the sine of 2 minus 2 then has to be negative. If I've got a number less than or equal to 1 and I take 2 away from it, I'm going to get a number that's going to be a negative number. So it's going to be less than 2. So what do we have here? So we have f of 1 was greater than 0 and f of 2 is less than 0. That's perfect. That's exactly what we need. Okay. Notice 0 is between f of 1 and f of 2. So we can use the intermediate value theorem. And it says this means there is x value, which we'll call c, where c is between 1 and 2, such that f of c equals 0. All right. So how does that help us solve this problem? Well, recall f of x was sine of x minus x squared plus x. And we know that f of c equals 0. So that means the sine of c minus c squared plus c equals 0. If I bring now the c squared, the minus c squared plus c to the right-hand side, I'm going to get the sine of c equals c squared minus c. So c is a solution to the equation sine of x equals x squared minus x. And we're done. That's it. Hope that helps.